Okay, it started.
Thank you, sir.
Okay, so this is the problem. So why don't you take like 5-10 minutes and then I'll discuss the solution with you. So, so you'll have to answer these. So you have to look at the question that I've presented here. So it's based on that figure on the right hand side. And I'm showing you how aspartate is going to methionine, lysine, and threonine. And there are these intermediates which are present also. So we've ignored most of the things that are there in the pathway we ignored. And what we have to do now is to answer the questions A, B, and C for this question number 1.
Hello, sir.
Yes, tell me.
Yeah,
Somebody done it?
yeah. Good evening, sir. This is Adhiraj.
Good evening, sir.
Yeah.
This is Yash. Sir,
Yeah,
Hi.
we are undergraduate students and we basically got assigned to the course a little bit late on 20th January. So
Oh,
we
26th January, is it?
20th, 20.
20th, okay.
Yeah. So, sir, basically we had a lot of backlog for the course. So we were hoping if you could extend the deadline of the assignment one by a day or two.
ठीक है. I'll do that, no problem. Go ahead. What I will do is I'll see if I can put it on the system itself. So you can submit it there, else you can submit it separately. I was going to write that, but there were so many things happening today, I could not get back to that email.
Okay, sir.
correct. Thank you so much, sir.
Okay.
Sir,
Thank you, sir.
if it's fine by you, then please set it to
Yeah.
Monday. It will be really helpful. We also had 4 quizzes this week, so it was not possible to cover all the 6 lectures.
Okay. So, is there anybody else who is having a problem?
Sir Yash Gupta.
I know you and Adhiraj. Anybody else? Because others should know that this is only I'm taking into account only because you registered late, no other reason. So it's not that I'm giving an unfair advantage or something like that. So others should know that. So if there's anybody else, then I would have to consider that case also. If not, then it's okay for me if the two of you submit that later. Okay. So it seems okay. It seems everybody's fine with it. So that's okay. Now for the question that I just presented to you. What are your thoughts on this question? Have you been able to think about this question and see how this needs to be done? Normally, how many students are attending this class? I mean, I just don't worry about the attendance, but I only hope there are enough students here. 10, half the class, essentially. So are you able to do this problem that I just give you on the screen here on the?
So we under like under.
Huh?
We are underway. We are underway.
Yeah, okay, carry on. Let me know. Has anybody got the answer? Natnesh, normally you are quite active. Shantan, one person has left already from this group. Out of the 10 who had attended just now, there are 9 now. So who left?
So like I had some sort of a confusion. So for calculating the determinacy of the system, we'll like first
Adiraj is also left.
basically just take
This fellow Adiraj also left. Adiraj and who's the other fellow?
not sure. So.
They were here. They just took the permission and they left. Is it from the class? All right. Okay. Anyway, sorry, I interrupted you. Carry on. We'll discuss this problem.
So for the determinacy of the system, like we just calculate the number of equations and the number of metabolites, right? So if and we like subtract both, so the number of metabolites minus the number of equations.
Okay. So the fluxes. So just tell me. Let's go through this. So now tell me. So this reaction screen, now you tell me what are you defining as the products? What are you defining as intermediates? What are you defining as substrates and things like that, right?
So I guess the products should be all should be lysine, threonine, and methionine because all of them are being produced and they are not undergoing anything else, like any other reaction.
Okay.
After that.
So the substrate is
substrate is going to be aspartate.
Yeah.
And the intermediates will be
aspartylaldehyde.
Aspartylaldehyde and homoserine in this case. Clear?
Yes,
all of you are clear?
Yes, sir.
So how many reactions are there? 5 reactions. How many intermediates?
So two
intermediate
intermediates.
metabolites. Right. So how many degrees of freedom you require?
So we have 5 reactions and 2 intermediates, so it becomes 2 minus 5. Right?
Yeah, 5 minus. So not the products. So you're looking at the total number of reactions. That is 5 reactions are there. Minus the two which are going to be the intermediates which are there, which are the ones that are going to be the variables, right? In this case.
Yes, so it should be 2 minus 5, so it becomes minus 3, right?
Yeah, 3. So 3 other 3 measurements are required, which means that you have to measure all 3 products. You have to measure lysine, threonine, as well as methionine. Okay, to get, if you want to get the entire system evaluated, which means that in this case, to get the other 2 values, if you're not measuring aspartyl aldehyde and homoserine, then to get those values, you have to measure 3 components here in this case.
Yes, sir.
Clear to everybody?
Yes.
Yeah. So, so this problem is actually trivial because you could solve it without going through the entire process. Okay, and I'm going to show you that. So you can see that, I could say this to get it exactly determined, of course, that's what you're talking about. And look at this, so just looking at the fluxes and the balance of the fluxes, you can just straight away write the equation. Right? You see, the answer is straight away because all you do is go to this point and look at how methionine and threonine is being produced. And then you look down from aspartate where you're getting. So straight away you will get this result that is given here. So if you draw a circle around this, then aspartate is going to lysine, methionine, and threonine. So if I want methionine, then that is aspartate minus lysine minus threonine. It's very simple, right?
Yes, sir.
Clear?
Yes, sir.
So this was actually done. I mean, I put this here paradoxically because this was when I had given this problem and I told student, I did not say that you have to use the flux analysis method that I said, although the answer is trivial, you can self-verify it. Somebody wrote this answer and I couldn't take away marks. I had to give him the full credit for it because I had not mentioned when I gave the problem the first time, when I created the problem the first time, I did not mention that you have to use this method that we had learned for doing this kind of solution. And so this is correct actually. So all you do is a balance around this point and you can get the answer, which is correct. All right, but let us look at the solutions that do come about if you were to follow the procedure. Okay. So let us look at this. This is actually showing you that if you were to this is not exactly in this. Okay, fine. Let's look at this the way it is being done here. But what we're saying here is that 1, 2, 3. I'm making only one measurement here. So we calculated for V3. This is incorrect actually. This will be V5. It should be V5. Okay, so what we are saying is that if you wanted to go around this way, then you would get this matrix, which is the G transpose V, which could be used to construct the G transpose V. And then you could say that, well, if you were to make 4 measurements, then this is what you get. But there is a second part to the problem, I think. I didn't mention it. I didn't mention it here in the problem here. This is part C. So if methane is also measured, can you improve the estimates? If not, explain why not, things like that. So what he's saying is that if you were to also so I think in the first part of the problem, what we did, we said, I think in this one, we're seeing that aspartate is being measured, not methionine, right? I think that's the way I framed the problem. Yeah, so what I said is aspartate, lysine, and threonine. So any 3 measured. So I had said lysine, methionine, and threonine, but actually what we are doing is aspartate, lysine, and threonine. Now, if I also measure methionine, then how can I improve the result? Is the question. Okay. So if I were to just do this one, have you done this with just 2? So for this problem, if I were to make 3 measurements, V1, V2, and V4, right?
So
then
V5, right? V1, V2.
Then V4, when
sorry.
V3 and V5 can be easily determined from this set, right? So in that case, this would become V3 and V5.
Sir.
Yeah. So has anybody done it this method and found out what the answer is and whether we get back the same answer as I showed you in that one line?
So I wasn't very sure what to do in the last part, because how do you explain if the efficiency would be better?
That is the second part. So that is coming here. No, that will come out. It'll give you a slightly different result. So if you were to measure methionine also, which means that you're measuring V4 also, then can you improve the set of the results that are here? So what is it that we're getting here? 1 minute. Let me see. What have I asked here? So threonine. I'm looking at lysine threonine, but I'm measuring aspartate. This and I'm measuring this also. Then can I improve this? I'll have to look V2 and V3. Sorry, this will not be V4. This would have been, this is V5, okay. This can't be V3. So I'm improving that here. If I'm measuring methionine also, 1, 2, it's that one, threonine. This is 3. This would be 3, is it?
So it should be 4 itself, right? Because the measurement of methionine.
No, that's all right. The homoserine is not in. The homoserine is the one we're looking at in between, right? So I made a correction, but I think I made a correction in the wrong place. So this one should be V3. This is okay. But I think this will be V4 and V5, right? But I don't know now. I don't know if I'm doing it ad hoc here. So 1, 1, 1, 2,
Yes, sir. That's V4 and
1,
V5.
2. This is not 3, so this is 4, 3 and 5. This is
4 and
4 and
5.
5, right? 4 and 5. 4 and that is 5. Okay. So that's what should be there. Okay. So I think this is the correct form of this. Now, if you look at this, then you should be able to get this equation finally. So this is an improvement over the previous equation. So where we talked about, so does this make sense? V5 is equal to V1 minus V2 minus V3. Let us go back to this figure here. So V5 is equal to V1 minus V2 minus V4. Correct. So that is also correct. So we are not able to improve that, but yeah.
So it's the same result we get from the
You're getting the
previous
same
equation.
result, and the reason why we are getting the same result is because we are not used any covariances or anything else. So automatically the same result comes in. Okay. So now look at the other method. Look at the method of Zai and Lee. Yeah. Yeah. So here again we are dividing. So can you just try this out and see if you could break this up? Can you get these two values V5 and V3 out of these three measurements, 1, 2, and 4? Can you try this out? So you see here that I have actually broken this up into two parts here. So this is the identity matrix I, 4 by 4. Then you have the 0 vectors, and then the corresponding G transpose. Here we have put V3 at the end. If you notice, we have changed the position of V3 to the end, and V4 and V5 are here. So now using this transposition that we have got, can we compute V3 and V5 from this uh, matrix equation? Do you want to try this out for a few minutes? So I'll Ronald do this now. You try this out.
So could you show the presentation?
Oh, sorry. Just give me a second. I've actually ordered for a pad on which I can start writing and then demonstrating things. So that will most likely happen from the Tuesday class next time.
So from this, from the last two rows, we can get V1 minus V2 minus V3 equal to 0, and uh, V3 minus V4 minus V5 equal to 0. So I guess you're muted if you're saying something.
You are not audible.
Sir, we can't hear you.
Can you hear this? So this into this minus into this, which is -1, right? And the determinant is also -1. So minus of that. So the cofactor of that will be -1. So the next figure that is next, this is the one. This is the one. Sorry, this one you need to see. So this one. So this is okay. This is the JCC the.
Yes, sir.
This is the right. This is correct. And then from here, if you were to invert it, you get the right answer here, as we see. So if you multiply this out, are you getting this? Is this correct?
Yes, sir. Yes, sir.
This is correct, right? So this is correct.
That is yes, sir.
Now, if do you get this component now correctly? This part. So this is going to be TVR. So this is the one that we have to now invert. Now, because this is non-square, so you'll have to apply this component here, which is so this is going to be V1, this is V2 or Vm, which is what we have written here. That into V1 is equal to and 1, 2, and that is coming from the previous slide here. Where are we now? This one. So this is the 1, 1, and this is the 1, 2. Okay. So in fact, you'll have to go through the whole calculation here. So this is shown here. And the TR is like this. If you work this out, that is this minus this. So you'll get four into 3, 4 terms here. Why am I getting this wrong here? So this is the VM, okay. So the VM is this, all right. So then you get this V1 is equal to V1. That's V2 is equal to V1, V2, V1, V2 equal to V2. Forget about that also. V4 is equal to V4. So the last one is only one, which is Y, which is the only result. That is the result of this one. So V5 is equal to V1 minus V2 minus V4. Or you can write it reverse. V4 is equal to V1 minus V2 minus V5. So the result comes from this last line that you see. Okay.
So but the result
1,
will be
1, 2 equal to 2, 4 equal to 4 is what you get from the first set. And the last question is the last line is what gives you the result, which is again the same result that you found earlier, right?
Yes, sir.
Yes. Yeah. Okay. If there was a variance, then you would have done it this way. Forget about that part. And, not discussing that here. So on the first, so I'm going to give you another question. So on this method that I just showed you, Sai and Lee's method. So would you be able to do this by yourself after this? At least see how this is being illustrated and then see if you can do it yourself.
So,
have you
so
understood the
thing.
illustration that I've shown here? Any questions on this?
Yes, sir. So just one question not related to this, but like, can you give us an example where like changing what we measure makes the measurements better. Like the way you said that if
Okay,
we
I'll have
measure
to do that. I don't have that with me here. I'll have to prepare one and then show it to you. It's not there on this
Fine,
set of
sir.
slides. So okay, I'll take care of that. Maybe in the next class I'll show you. Okay. I don't have it ready because you'll have to have numbers that do it. Here I have, only the theory shown here. Okay. So this has to be done with, to show you how this whole thing is done with, one example of that kind. All right. It's not here. I have to prepare that example because there is a requirement of getting all these estimates of the variances and then do it. All right, let's look at this problem now. I've given you another problem. So this problem is asking you that, if given in the figure, we are seeing the a part of the tryptophan synthesis pathway. Quite a lot of simplification has been done because from glucose 6-phosphate, you're going to DAPH, and then from there, you're going to chorismate, and then so on. So you have phenylalanine, or this is called and then you have got tyrosine and tryptophan, which is being produced. Okay, and then there are 6 reactions that are given to you, and in this case, you are required to figure out what would be the intermediates and what would be the products and what would be the substrates, and based on that, say whether you are going to have an exactly determined system, and then from there derive the relationship between or the unmeasured states. If you were allowed to measure the fluxes that are required, can you now compute phenylalanine and tryptophan? Or tryptophan, not tyrosine. Okay, check this out. Try this out now. Problem. Spelling mistake.
So for ATP to ATP, we only consider it as one, right? One metabolite.
So have you been able to get to some level with this problem?
We have 6 reactions and we have, I guess, 4 metabolites if we consider ATP and ADP as a singular one.
So that is going to be you need to make a call on this here, because ATP and ADP, as you know, are always a problem whenever you're doing this kind of analysis. So you have to, in this case, you see what is going to happen is you're going to get a one-way equation only. If you were to do ATP balance, and 2 ATPs is giving you 2 ADPs. So it's a one-way equation, which means that if you were to consider the intermediates, there is no way that you can actually talk about this as being intermediate, because that ATP balance will not close.
So
Right.
we can just call it a consumption of a phosphate that we can denote by an ATP consumption and not involve any ADP at all.
But in this case, what will happen is, essentially what will happen here is, because of the nature of ATP and the way it appears in the cell. So actually, what you assume most of the time is that there is enough ATP in the cellular pool, which is there, and therefore whatever ATP is the demand, that will be fulfilled. And most of the time, whenever you have a situation like this, the ATP is not considered in these smaller problems. They're mostly considered in these larger networks where you have both synthesis and consumption of ATP. In those cases, you can work out an ATP balance. In this case, you cannot, because it's small. You can see the number of reactions are smaller. So in this case, I would suggest that you ignore the ATP balance and then work out the problem. So say that the ATP balance cannot be closed, and therefore it is ignored for this problem.
So basically, do we consider ATP as a metabolite or not? Like,
no, don't consider it as a metabolite here, because you will have a floating. You'll have you'll get a matrix which will then have one of the columns which just have to be dropped later on, and it just makes no sense. So if you work it out and you see with ATP, you'll find that one of the columns will just drop out. So it doesn't make sense to have it there, because in any case it's not going to be of any use. Okay. So I think in this case, just drop it and consider the others.
And sir, if we consider ATP as a separate metabolite and then add 2 columns, then it would just be trivial, right?
If you add,
Sir, like if we add, like if we consider ATP as one metabolite and ADP as another, and then
no, that's what. See, they always come in pairs. So if you can't consider ATP as independent of ADP. Similarly, for the reductive components, NADP and NADPH. So if you just do then you'll have 2 columns. If you have ATP and ADP like that, then 2 ADPs getting synthesized will be one of the components, and then 2 ATPs getting consumed is another component, and both of them will be independently then giving you a problem, and those have to be dropped out from the calculation once again. When you come to that stage, you'll find that they are just essentially going to be redundant. You have to remove them out, and it doesn't work out. So it's better to drop it right in the beginning here in this case.
so then we have 6 equations and 3 metabolites.
6 equations and 3 metabolites.
Do we do the same for hydrogen ions as well in any reaction?
No, hydrogen ions.
Yes, sir.
H plus.
Yes, sir.
So hydrogen ions, it depends on the. See, it depends on if the system is dependent on the pH and all that, right? So if it is dependent on the pH and you're supplying pH from, you're supplying acid from the outside to compute the balance, then you'll have one constraint that comes from there. In that case, you can use it. Else, you sometimes do have a system where hydrogen is also being produced. There you can use it, but as a part of something that comes in the water and then it is actually adding to a reaction. In those cases, you don't consider it. Then you assume that the cellular pool has enough water that all the hydrogen that is required can be met.
Fine.
So this is where that little bit of understanding of the biological system is required. So you get my point?
Yes, sir.
Yes,
Suppose you have a problem where you're framing this in a fashion where you're considering, that there is a pH dependency and you are controlling that pH from the outside, then obviously you have to account for it. So it comes from the context of the problem. All right, so shall we proceed with this solution of this problem then? I show you and then we discuss it.
Sure, sir.
Okay, now, so look at the reaction pathways. So V1, V2, V3, V4, V5, V6, and you can match it with the results that you have on your paper that you're working out with. So 6-phosphate and PPA is getting consumed in the first reaction and DAPH is being produced, clear. So likewise, you look at the last reaction where you have codismate and then you have glucose being used, and then that is giving you tryptophan. But you have this ATP-ADP pair also coming in, and this is something that you need to ignore. You also have another ATP-ADP pair in the second equation, which is ignored. So the ATP balance could not be set up because only anabolic metabolism being that is being used, and so it will not close. So it's better to exclude it from this analysis. So the substrates are 2, the products are 3, and the intermediates are 3. So that gives you degrees of freedom 6 minus 3 is 3. Therefore, you have to make 3 measurements to make it exactly determined. And this, if you look at the general equation, then this third component which is there, the macro component is not required for us, but the component AS, BP, and GMET, XMET is the other component that we need to set up. So if we set up the reactions, then what we see is the way we get the formatted in this in the vector form with the matrix and vector form that we showed in the previous slide, and you find that the consumptions of substrates are shown here, the products are shown here, and the intermediates are shown here. So if you write this in the format for the metabolic flux analysis, then G transpose V is equal to 0. So you pick up the G transpose V from here and put it here. So V1, V2, V3, V4, V5 are the individual reactions in which each of these components are participating. All right, now look at the next one. So I think it's a little dark, but I hope you can see this. So can I change the color of this? I think I just increase the transparency of this.
No, so we can see like it's not.
Yeah. Because it's a little darker than I expected. Okay, this one can be more color. So you can see that the GCG transpose to get the, so that will give you the pseudo inverse. So you get this format, which is very nice and easy. And then that transpose times GC is going to be the pseudo inverse. So that multiplied by GM is this whole component here. Now, when you bring it back here, then the component that you're measuring, V4 and V6, are going to be based on V1, V2, V3. So then you get this result. V4 is equal to minus V3 plus V5, and V6 is this. Now, V1 does not contribute to at all to the estimates of V4 and V6. Now, this is something that usually I ask the students to discuss, because where is the reaction here? So V1 is actually the glucose coming in. But because I asked you to find out V4 and V6 here, which is tryptophan and phenylalanine, right? So it's
but
all. Yeah?
So the thing is, like V2 and V3 would depend on V1, right? So like they
Yeah.
automatically, so V4 and
Yeah.
V6 automatically depend upon
Correct,
V1.
correct. So essentially the balance is right here only. So you don't have to worry about the other things coming in. So that is the reason. So it's not incorrect, but it's essentially not. I mean, so rather it is, since we're doing this in the fashion that I showed you here. So it shows you the immediate dependence. So there is a V2 here. So just keep in mind. And so therefore that should take care of all the other dependency which arise from the first step. Okay. So this is showing you obviously, the simplest way in which you can compute V4 and V6. So do you see how this works out?
Yes, sir.
All right. There is another example here. So this, what I think we'll stop here. This I think you can work out. There are a few more examples, I think. So this I will not do in the class. Maybe you can look it up when I upload the slides, and then you can use that to kind of do your own practice for this problem. Okay. So previously this used to be in class exams where I used to kind of design these little pathways that can be quickly computed and not giving a student more than a third order inversion to do. So a matrix with 3 by 3 matrix will be the highest matrix that somebody would have to invert in a class. So that then it's just quick, and all the zeros and ones, so it works out. So any questions on this so far? Okay, there are a few other things that I wanted to talk about. Let me see if I can. I'm going to just reduce this and bring up another slide here. So can you see the screen of mine now?
Yes.
Yes, sir.
So I sorry. So I'm actually making a group now, making 5 groups, and I've tried to distribute it equally with the different streams so that you have balance of all of them. But we can't do it perfectly because we have extras from biochemical engineering coming in. So I only hope that this is something that is acceptable to you people. So at least those who are present, are you okay with it?
So can we make the groups ourselves? Like, would it be possible?
You want to do that? Okay, I'm okay with it. Yeah, I'm okay with it, but I don't want more than 5 groups, 4 to 5 groups. Okay.
Sure, sir. So like group of 4 would do, right?
Yeah, 4 that will give you 16, but we have 18 students in the class. So if you make 4 groups, then there will be 2 groups which will have 5 students.
That won't be an issue, sir. Like, I guess.
For me it's okay, but then usually when you have more than 4, I think people don't work. So it's better to make 5 groups.
Hello.
Fine, sir. So, but still, even with 5 groups, some groups will have 4 members, right?
Yeah. So you have more of 4 and 2 of 3 in that case, which is more acceptable, because then the 3 will definitely work, and of the 4. So if you have 5, I think 2 of them become redundant anyway. They don't work so hard, things like that.
Right.
Sir. Hello.
Sir, my name is not listed here. Like.
Yeah, I don't know. I mean, this is the. Please check with the UG section. The academic section now. The reason is, I just picked this up today morning. Before making the group, I wanted to make sure that people who are registered are in the final list. And this is the list I got. I actually modified the list I had previously. So I had the master sheet that I had earlier. I changed that, and from there I made this now. So can you please check with your, why your name is not there? Because you will be sitting through the course and then you will not get credit for it.
Sir, I don't know.
You've been here throughout. You've been here right from the beginning.
I am here since first class. Like.
Yeah, you're here, but your name is not there, right?
So my name is also not here.
Who is this?
Naveen.
Naveen, your name was there, but it's not registered. I removed your name today from the list. I also looked at the name. I said maybe you're dropped or something.
No, sir, I haven't dropped. I'm registered only.
Okay, Naveen. I'll include your name. So I'll have to go and check. Maybe I'll just do it right now only and put your names here so I don't miss out your names.
Oh,
So tell me your
so
tell me your entry number.
2021.
2020.
2021.
Ah,
SRC. SRZ.
okay, SRC. I saw your. I don't know why your name got removed. I
So
mean, not there.
SRZ.
Z. Yeah, I know. Okay. Yeah.
85770.
85770.
570.
Yeah, you're doing PhD, right?
Yes, sir.
Under Sire, right?
Yes, sir.
Okay. And Naveen Guru, what is it? Guru Naveen.
Naveen Gurupadam J.
Guru
PATHAN.
APHAN.
AM.
M K
J.
J. Okay.
Yes.
And Sunil, what's your roll number?
Sir, it is 2021
Yeah.
and BLG
PLZ. Okay.
8477.
A4 84. Sorry.
Yeah.
Yeah. 8477.
Yes.
Hello, sir.
Ah.
Sir, my name is also not there.
What's your name?
2021
2021.
BLY
Sorry.
BLY
ELY
7573.
7573. And your name is?
Kavan
Huh?
Thakkar.
Kavan, you were also there, right?
Yes, sir.
Kavan. Correct? Spelling is correct?
Yes, sir.
Okay. J Thakkar. Okay. Okay, I'll look up this and find out why, but please check why your names are not there in the list. Okay.
Yes, sir.
Yes, sir.
So I'll also check if they separated out the PG from the UG, then it will be different, but I don't see any other reason. Okay, so what I then expect is there will be, you can make 6, there'll be 21, right?
Sir,
So
Excuse me,
there
sir.
are few students more, I think.
Huh?
So,
So
in the
even
course mailing list, there are a total of 27 students in this course. In the mailing list.
27 students, huh? Okay.
Yes, sir.
Oh
Like-
my God. Okay, then
Sir.
I don't know why I saw this,
Yes.
I'll check. Then maybe I'm making an error here. I will check again. So
yes, I guess there's some discrepancy because there are 2 second-year students which has joined. Even they should be.
Yeah, they are also there. So I don't know what happened. So anyway, good thing that I brought this up, and now I'll check this again. So in that case, we can make 6. We'll have to make 7 groups, right? No, 27. Yeah, 7 groups. 6 4s are 24, and then 1 will be 3. So those who are present here, maybe so you are more than the divisive number which is there, 7. So each of you can pick up your team and tell the others to make a group. And I was thinking of having an intermediate kind of a discussion topic which I will give for each group, and then we can have 1 slide or 2 slides and have a presentation. And so that will be like an assignment which will also help you earn some marks. Okay, and to be easier when we come to the final grading. All right. So I was planning to do that. So can somebody among you, I mean, few people among you volunteer and get me the group in 3-4 days, 3-4 classes at least from now. 8th, I would like to have everybody's name.
Sure, sir.
Yeah,
So,
because
So
next
could you
week
please send out a mail as well?
yes, on the course mailing list. So, like the people who couldn't join today, even they'll get.
Okay, I'll do that. I'll mail it out. Okay. All right, I'll do that. and I also check the list and then get back to you. So I was quite surprised that we have 18 students, and I was thinking, then we are only having 1/3 of the class present most of the time, not the whole class. That's also surprising. Okay.
So should we choose the topic ourselves, or would you allot it to us?
No, there will be 2 levels of it. One topic I will give you just as a practice so that you start vibing with each other as you make a group. So I'll give one topic with 1 slide or 2 slides to present so that we quickly see how you are doing coordinating and doing things on a small things which you've already taught in the class. And then I will give something that I'm not taught in the class, and then we'll give topics which will be at the end of the course. Okay.
Yes, sir.
So that would be the second assignment, right?
Yeah. So it'll be like part of an assignment I'll give. I
Okay,
want you to kind of do some work.
And so would the term paper be in groups or would it be individual?
No, it'll be in groups. So choose your groups well. Get yourself with somebody and who can work with you.
Fine, sir.
Okay. And there'll be one like an assignment, which will be a small, not too much, but just 1 or 2 slides on one topic for speaking for 2-3 minutes each person, maybe I don't know, we'll see. Or each group maybe 5 minutes, something like that.
Fine, sir.
Okay. All right. So bye for now. And tomorrow we have a class. So I'll see you in the class tomorrow.
Thank you, sir.
Thank you, sir.
Bye. Bye.
Thank you, sir.